Oh, no.
We are recording.
Cool.
We're recording now. So you've given your consent. Hi, everyone. Welcome to Live Contract Review. Guest hosts, Matt, Mike, Austin, Jim, figuring it out for the first time on our own without Eugene.
Hi, this is Eugene, and we are going over another live contract review today. This time we're going over the non-fungible token. And this is pretty interesting because unlike some other examples that we've shown, we are going to be using near contract standards, which, as you can see highlighted right here, is actually in a different crate at the moment. So typically what happens is if you want to take an example and build off of it, you would copy paste the whole thing. And we've seen that in a number of different cases. Like, let's just take a look at status message, for instance. This is a very simple example. So a typical use case might be you think this is pretty close to what you want to do. You just copy the whole thing, paste it, blah, blah, blah. So that's not really great for scalability, obviously. And so we created this thing near contract standards that has a few different standards that you can actually implement. So we have storage management, fungible token, and then the most recent one is non-fungible token. So this we'll get into a little bit later, actually, but this has like the implementation code. But what is the actual example itself? So the actual example itself will have like way less boilerplate, and it's going to be saying, hey, I want to grab a bunch of logic from near dash contract dash standards crate, and that's going to make things a lot easier. This is not totally set in stone how we are going to do this, but this is the current iteration of how the contract standards work. Should mention that. So non-fungible token, NFT, you'll note that there's a few other projects in here. This is mostly for simulation tests to make sure that like we can transfer NFTs and all the expected behavior is happening. As normal, we have our source lib file. First, let's go into cargo toml. And when we're inside the near SDK RS project, this is also a really good way for our continuous integration to make sure that like any changes we made to the SDK are still kind of working. So here we'll use relative paths. So for the most part, if you are trying to take this example, copy it out and then make a standalone example, you're going to want to change this so it's actually using versions instead of relative paths. And this is something that we do for all of these is we say basically this is a lib, which makes it say, hey, I'm going to look in lib.rs. So let me close the panel on the left. Oh yeah, much better. Let's add word wrapping, much better. So what I like to do usually is just scroll all the way to the bottom just to see like how big this thing is that I'm looking at. So digestible, 331 lines of code. And how much of this is tests? A whole lot. So at the end of the day, we're talking about 114 lines to make an NFT, which is great.
I got it down to like 88 lines somehow.
Boom.
Maybe I cut the comments.
Did you add comment? Okay, well, the more comments, the better. It should be longer. So back at the top, now that we know that it's like 114, it's doesn't seem too scary. I like to always start with that. Then at the top, as usual, we've got these imports. This is kind of like boilerplate. If you're using an IDE like CLion, like we have here, a lot of these, you can just start typing and it'll automatically import them. This is actually something that will be a relic of the past soon, thanks to Austin, who's on this call. And so this is nothing special. At the top, we have our kind of main contract struct. This is the one that we use the near bind macro for, and we're storing tokens and we're storing metadata. It won't get too much into this guy, but essentially we really want NFTs, which are especially right now in the zeitgeist, big in the art scene. And so being able to have like thumbnails of like what NFTs do you own makes a lot of sense. So this is a URI image. Can't remember actually the exact term for this, but we can look at Namicon if we wish. This is something that isn't that worth going over too much, but essentially when you have collections, like say, like a hash map, except better, just like a map between key and value. And then you want to have like key, and then the value is also a collection that has a key and value. Things can get kind of interesting in terms of how we write state in the blockchain. So this storage key sort of helps to make sure that when you have collections inside collections, that it works smoothly and there aren't any sort of conflicts and overlaps. Okay, this is something that I think I hadn't really seen before. So notice that we're implementing our contract struct here. And we've got this init macro twice here. So init usually means like, hey, I'm going to be calling this method. Don't worry about what's in state. Don't take what's in state and try to shove it into the primary struct that we're talking about, which is this. So this is typically called once, these new methods. And the most common way is you check to see if it's already initialized, so this can't keep getting called multiple times. So in this particular case, we have two ways to initialize. One's called new default meta, and the other one's called new. If you look at all of our examples on near.dev, the website, you'll see that this second one that I'm highlighting here is the most common pattern. But this is sort of an easy way to just say, hey, just give me kind of a basic NFT metadata, NFT with metadata initialization. This one, you can get more granular with it, where you pass in an actual NFT contract metadata object here. This is probably what you'll be using in real life. And we will get to metadata in a bit, because there's kind of two kinds of metadata, but that doesn't matter. When you're initializing an NFT contract, of course, you're going to be putting in the NFT contract metadata. So this just initializes this. And then this is basically like a customization. This does not exist in the standards necessarily. NFT mint. Now here's where things get much more interesting. And again, I don't know if this is going to stay this way forever, but this is how it works now. Is we're saying, hey, there's this crate called near contract standards, and there's a macro that goes through in there that will implement essentially the interface functions for the non-fungible token core. So this is, for instance, like the core methods like NFT transfer to another person, NFT transfer call, which is similar to the fungible token standard that we have, if you've seen that video. So someone might just have this, like they may not even want anything else, and this is fine. The way that we want to deal with like extension standards is being able to have a person add just one line of code that says, hey, it's cool that, you know, we have these kind of the core standard methods, but I'm pretty used to the idea of saying like, hey, I have an NFT, Matt, I want to allow you to take that from me. Like, let's say it's like Christmas time and I'm an artist, and I say, hey, Matt, I'm going to let you take one of these 3 paintings that I've made into an NFT. I can like allow him to like take it on my behalf. This is becoming a little bit of a old pattern, but nonetheless, there are good use cases. This is sort of a similar way of like thinking that happens in developer communities. So you can add this, and then enumeration, very important, but not like required in the token core non-fungible token core standard. Enumeration is basically like, hey, how many NFTs does Jim have? Please like give me a list of the NFTs that he's got, and how many do we have in total, and let me page through all of the ones that Austin has, because maybe he's got like 600 and you can't return all 600 with one call. So in this case, we've decided that we want to have like 3 extension standards. Then this essentially ends this particular contract, which is what we would only copy paste into our own project if we want to. Any questions before we jump into like a little bit of the code from here?
Yeah. So I have a question, and it may be a little early, but I wanted to know what's the optimal strategy for a developer to, I guess like the technical term would be, override a standard method. So for example, you mentioned this, let's just talk about a transfer. So I want to send you an NFT, but I want something kind of special to happen during that transfer, or I want something to be incremented, like, hey, I'm a token and I've been transferred X amount of times. How would you go about doing that after this macro has been applied?
Yeah, that's a good question. I think that you would actually want to be diving into the contract standards here, and it's possible that Austin knows more about this, but I'll just mention that real quick. I will say that maybe we can just switch gears for a second to the fungible token instead of non-fungible token, and where we have FT here. There is a pretty good example of this where okay, so these two functions right here are kind of similar to what you're talking about. But well, first of all, to answer your question directly, I don't think that there is some sort of like hook into this to say, please don't do the thing that the code says and do this instead. This is getting pretty close to what I believe you're talking about, where we have in the fungible token implementation something that says, all right, someone just closed their account. Basically, like, you use DAI for a bit, and then you had a little bit of storage saying like, hey, I paid for Mike.near to have a key value pair on this fungible token contract. I really want that teeny bit of storage back. Then you can like remove your account and get that teeny bit of storage back for yourself. And then when that happens, we have something that says, hey, by the way, if there is like a function called on account close, then just go ahead and call that. So then you get kind of best of both worlds, where your entire contract is 103 lines and you like have all the logic you need, but this just kind of calls back to here. So I guess this is a little bit similar to like a hook like pattern that you may see in other like frameworks. This is currently, we don't have this for NFTs. So if you want a bespoke one, then you're going to have to look in your contract standards, as far as I know, and modify it there.
I have an example also of a fungible token. So one thing that we had to do for a recent project was we had to lock down a fungible token and basically say that the only account that was allowed to transfer the fungible token was a particular account. And then also the fungible tokens were only allowed to be transferred to a certain account. And the reason for this is that this was sort of like a casino token that we only wanted to be used in the house. So we didn't want it to actually, we didn't want this fungible token to be able to be taken out of the door like the chips in a casino, and taken to another casino. So probably should stop using casino metaphors, but basically we just wanted to keep control of our sort of credit system. We were using this for like on-chain accounting. Basically what the developer, this was Ryan Mehta from Developer Relations, what he did was he simply just didn't call the macro, and then but he still had the object, like the underlying token object and all of its associated methods, and then he just simply wrapped the methods that he wanted to keep standard, and then the ones that he needed to modify, he kind of just like he still wrapped it, so he still called it FT transfer, and then he put a little bit of an assertion at the front that said predecessor must be so and so, and then he just called it after the assertion. Is that an okay pattern, or is that some pattern that's like, is that an anti-pattern?
So does that mean that he, if you can still see my screen, does that mean that he like removed this impl non-fungible token core? If you're Is that what happened? And then kind of put some of the logic in
He
this
did
file
this
itself?
he did this for fungible tokens, but this is the exact thing that he did do. He basically just didn't include the macro, and then he just went through method by method and just wrapped. So the ones that were standard, he just like FT transfer and then self.token.ft transfer, So
Sure.
and then for anything else that he wanted to customize, like I said, he just would sort of put an assertion above it and then call it underneath. I'm just curious if that is like, is that like a bad pattern?
I can't
Maybe
think of any other.
Austin has a
Yeah.
comment or.
Yeah, I mean, like I don't think it's necessarily a bad pattern, especially right now, because we don't like, as Mike said basically previously, is this stuff will probably be iterated on and make it so that it is like kind of extensible and customizable more easily than it is currently. But I think it is an anti-pattern as long as it just depends if someone is expecting the exact like NFT interface to be used. Like if that has changed, like say if you actually are wrapping the function itself and like calling it something different, then maybe like someone using it might call like the inner function when you actually want them to call the one that's going to do the extra logic. So I think just be careful that if you are creating this wrapper to like make sure you're only restricting it to certain amounts, that you're either not exposing the one that's automatically being derived if you're keeping that line in, or just making sure that those invariants are upheld.
Yeah,
Nice.
I think that was the goal, was to keep the interface one-to-one, but really just, it's almost like not at that point, if you're scoping a fungible token and like limiting it, it's almost like not extending it. It's basically restricting it, right? But there are fields in the NFT contract that I think are like make for things to be like a little bit more flexible, like the memo fields and things like that. So yeah, I'm just wondering how we would tackle that, how we would like piggyback, put like custom logic in, transfer happens with a particular like message or memo field, and then something interesting additional happens, but then it just keeps on going with the core implementation.
I like that, especially because in this, what I imagine happened here is that basically if you want to say, I want to add one more assertion to NFT transfer, then you gotta like comment this out and then do all of the methods. Like you can't just say, okay, I want to change this one. So that might be something that would be cool to do, is, hey, I have some way of saying like, oh, I only want to hook into this one, and please let me use all the other ones, which would probably make things a little bit more error prone as well in the future. So yeah, great point.
I just thought of a terrible terrible thing to ask of you guys, but it would be like instead of implement non-fungible token core macro, I mean that macro could call maybe half a dozen, I don't know how many methods are in there, half a dozen other macros. And then so you could just wipe out this line, bring in 5 lines, and then change the one that you like, wrap the one that you wanted to change. I don't know what that looks like though from an implementation point of view, like kind of a macro to macro, kind of like it's like multiplexing macros or something. But
I mean,
Yeah, it's totally doable. Oh, sorry, I didn't mean to cut you off.
no, yeah, actually, you're way more about this than me, so I don't want to cut you off.
Yeah, I was just gonna say, yeah, it definitely is doable, but I'm just definitely being a little bit careful and I guess cautious not to like add a bunch of overhead that we might, move to somewhere else later. Because I'm not sure if we're going to keep this like declarative macro style that is the way that's right here. So yeah, it's definitely something that we should either iterate on and like come up with an example of the easiest way to override either some of the methods or all the methods, and then like keep that up to date so that people can easily see how to do that.
Yeah.
Cool. Well, yeah, I mean, that was like the real bulk of like my interest in looking over this contract, was sort of what do I do when I want to do something in like a little bit more kind of wild, off the beaten path, right?
Yeah. Cool. Let's see. I guess I think, Matt, you may have to drop off soon, but I think I can keep going on this for a little bit. Does that sound good? Or do you have like other?
I started the recording, so I'm gonna have to pass on something. So I just want to make sure I can do that. I'm going to leave meeting and I'm going to make you the host, Mike, and then that should give you the control functionality. Okay.
Okay.
I pray this works. It's still recording. Okay. Bye, guys. Thanks for answering my questions, by the way.
Yeah, for sure. All right. Yeah, so let's take a look at this. Some of this stuff, I don't think we have to keep it too long, but this is a great way to dive into this. I think the next thing I can talk about is something that was mentioned here, where we have two kinds of metadata, NFT contract metadata, and then per token, right? So this is maybe like, I'm an artist and I want to put my stuff up here, and this is like my anime like collection or something like that. This could be like my NFT contract, and then an actual piece. It's like, hey, this is Pikachu, which isn't exactly anime, but you get what I'm saying. That would be like a token metadata. So these kind of borrow one another, but we won't go into every single field here, but there is that differentiation. And then there's some helper method here, so a person can take a look and see like what's the information on this particular contract metadata, get some details on that. Okay, so that goes over those two different kinds of metadata. Macros, I don't think that's too useful to get into. A token here, this is super basic. We just have a token ID, an owner ID, because owner ID, a token can be owned, obviously. And then in this particular case, we have added approved account IDs. This is this thing where I said, hey, Matt is able to take this NFT on my behalf. So this is stored inside of a mapping here. In this particular case, we are using hash map, which is a little unusual. If you've seen other videos, we prefer to use near collections. This one, we are quite confident that it's not going to grow to be incredibly large and impossible to page through. So we are using hash map, and that's totally fine. You'll notice that the approved account IDs are
the near collections. Sorry, Mike, just a quick question.
Sure.
Are the near collections just like size limited versions of hash maps, just with a little bit of protection on top of them, or are they fundamentally different data structures?
Yeah, great question. And I'm probably going to butcher this, but basically like hash map, when you load this in, it'll load up the entire map into memory. And that is pretty bad when you talk about like fungible tokens, for instance. I'm a huge fan of basic attention token in Brave, and that probably has like, I'm going to guess like, tens of millions of rows. And so you don't want to try to load that into memory. And then in particular, like the other answer that I think you're getting at here, maybe I'll open up the status message again, is there are different kinds of, okay, so this also uses hash map, bad example. There are different kinds where it's like this uses an AVL tree, for instance. And so AVL tree is like balancing. So it'll, someone can't make a really, really long kind of side to the tree. It'll always like rebalance. But that also comes at the cost of like that rebalancing, and the way the data structure works is much more gas intensive than
inserts are a lot. So yeah.
Yeah. So
so it's in a distributed. I'm wrapping my brain around thinking about this in a distributed way.
Yeah, but
totally.
just add like one other quick context about the collections is just that the intention of the SDK collections is just to basically lazily load the things from storage, so that you don't actually have to do all the loading from storage and then deserializing up front, because you want to minimize the gas costs on chain. So if you can kind of only load and deserialize the things that you actually use, that's like obviously ideal.
Okay, cool.
Yeah,
thanks. I didn't mean to tangent there, but that was interesting to.
No, it's great. It's beautiful.
To think about.
And then so there's three directories here: approval, core, and enumeration. And this is basically just where we have the different implementations for what we have in our standard. And you can go to nomicon.io. In the left sidebar, there's going to be a standards section, and you'll see that these are all the functions. We got tons of more information on what you should put in, what you can expect to happen, when it should panic, all that kind of stuff. So here we're just saying, please get that please get this particular token. How many tokens are there? And then here we are doing a bit of paging, which is quite interesting. I don't think that we've done a live contract review where we talk about paging, and that's probably honestly its own video. But essentially, we're saying like, let's please start from here, and then let's have a limit of how many we want. And this makes it possible to say, okay, there are like 300 items, and I actually do want to page through this. You can do that without hitting the gas limit. NFT supply for owner. Once again, this is like Jim has 7 NFTs. Like, show me all the NFTs he's got. Oh, supply. Actually, sorry. This one would return 7, and then this one would return the 7 different tokens that he's got. So that's enumeration. And then the core contract has these methods. Again, this is all come from Nomicon. Resolve transfer, on transfer. For this one, I'm going to recommend we check out the fungible token video, because this is a bit to get into, but this is essentially a replacement, and possibly better than using approval management is the idea of having on transfer, resolve transfer, and what's it called? Transfer call. Yes. But yeah, I think that's for a different video. And then approval management for NFTs. This is where you can say, okay, you're cool. You're going to approve who? You're going to approve this person. And that's quite straightforward. This is also almost the exact same for fungible tokens. So yeah, I think the overall takeaway is that this is an example of using near contract standards. We are kind of iterating on how this is going to work, as we mentioned a couple of times, but this should make it so that you can just use macros to say, hey, I don't want to copy paste this whole thing. I want to, use macros for this. And then if there are updates to how these things work, like I can't imagine this, but like say that there's like a, security flaw or more like if there's a enhancement that we make to this, then you can update your crate and everything is going to be all good. So we look forward to making as little boilerplate as possible when writing smart contracts. And this is an example of that happening, making it 114 lines. And this is down to 113 from this recent change that, Austin has done with memory allocation. And yeah, we're going to keep doing this as best as we can and figure out some way to kind of add something like a hook system and maybe rethink this. But this is where it stands. It's actually some pretty good project, and we can look forward to experimenting with this on an upcoming multi-token standard that should be happening fairly soon from a community member.
Cool. Super cool.
Neat. Well, thanks for this.
Thanks for going through that. Yeah, gives me kind of an idea of what it looks like coming in fresh.
Nice. I had no idea I'd be doing this presentation, but hopefully it
Well
kind
done.
of made sense.
Oh, you did a good job of kind of covering everything.
Right. Well, thanks, y'all. I guess we can keep it to time then, and call it.
Cool.
Sounds good.
Awesome. Thank you, guys.
I got. Thanks, y'all.
Talk to you later. Bye.
Bye.